I'm on a new setup, so hopefully it works. Where's my... Ah, perfect. YouTube says excellent connection. Pause that. I think I'm in the correct live chat. Hi! I'll look at the camera more, hopefully. Where did Restream go? Oh, wait. All right, the Restream chat is off. It's not on the thing. Ooh, look at that bit rate. 450 kilobytes a second. How's it looking? Have to move everything around. All right. Are folks in the YouTube chat? I'm not seeing anything there. I wanted to start early because I'm on a new setup, so. I know Alvaro's in the... Sounds good, looks good. I'm not seeing anything in the YouTube chat. Nothing in... Ah! UTP216 says Twitch is working. Thank you, thank you. Fede2 says love the cat cam. Do we really not have any YouTube chat going on here? There we go. Thank you, Steven, for saying I'm in the YouTube chat. Looks fine, sounds fine. I'm going to turn that off. So you will have to let me know. I've been having problems with this camera freezing. Matt Lamb is testing as well. Thank you, Matt. This overhead camera is not frozen yet either, which is good. And the nice palm trees can demonstrate to us that the cat cam here is live. I do actually have a large version of it. It's a little blurry because the camera's not spectacular. It can do HD, but it doesn't really slow frame rate. So I thought I'd leave it on the blurry because most of the time it'll be small. But I thought I'd make a big version. Robert Rand says sound. Fred Hayes says afternoon from near Pittsburgh. I think the sound is working on the other streams. I do not know about Periscope. But you should be able to hear me. There is no cat cam sounds, though. Yeah, so we're getting going a little early. I'll actually start chatting more at 2, which is like 4 minutes from now. But as I said earlier, I'm on a new setup. No sound. Yeah, I mean, other people in the other chats said they can see and hear me. YouTube sounds great. Thank you, David. So I want to know, do you think that the quality is better? And thank you, other David, for saying sound is working here. All right, I chatted on the restream back to the Periscope folks, hopefully. Yeah, the chat is delayed. That's something that's been typical. Thank you, Matt. Hi, Happy Team Forever 2. Welcome to the stream. UTP216 says Twitch sounds good and video is good, so thank you for confirming that. Audio is clear. YouTube, thank you, Craig. Zool says hello. Sorry, Robert. Audio is fine as Twitch as well. Thank you, Alvaro. That's kind of nice. I can like see the... So I was setting up OBS. So I used to be streaming from my MacBook Pro. And now I'm streaming. I have a... Oh, good. Steven says the audio is much more in sync than the previous streams I watched. Yeah, so the thing is that I was streaming from my MacBook Pro. And as you know, this room gets pretty hot. And it kicks up the fan, but I think it also dips down like all of the like CPU and the GPU speeds, which means that like it has less compute power. So I have this computer sitting under my desk that I usually use for gaming, and I had Linux on it, and I was like, why don't I used to like bring my laptop downstairs and work at the couch and stuff, and I've stopped doing that. So I was like, why don't I just set up my Linux box, my gaming PC, as my work computer as well, just dual boot it. And then I don't have, like, I can be very specific about like one camera per USB bus in particular, and have a bunch of USB buses that I can use for all the different cameras. So I've actually got, and I guess I'm getting ahead of myself because I wanted to talk about this anyway. But yeah, that's I'm hopeful that like I'm using a computer now that will be have a lot more grunt and be able to take care to be able to handle everything. Traveler 3000 says dodging flashbangs here in Portland. Stay safe. Matt asks, do you have any fun cat CircuitPython projects, cat tracking, feeder, etc.? I do not really, actually. I don't do a whole lot of CircuitPython projects myself. One thing I did was there was a leak up here, so I did a thermal camera. One thing I think this camera is better at is it might actually be better at focusing if I block my face. Like, look at that. Ooh. So I have that on my desk. And yeah, so that's the last project I did, was monitoring the temperature of this wet spot in the office here. But no, I haven't actually done any cat projects. They're indoor cats, so they don't go very far. And feeding wise, I feed them wet food, and Spook, who you can see in the camera here, he's the cat with epilepsy, so he gets pills as well. So I can't just use like an automated feeder where it just opens up. It's unfortunately more complicated than that. In terms of MacBook Pro, Stephen Benke says, you'll see a process called kernel task when your machine is being CPU throttled due to heat. I see it a lot while compiling my project. Yeah, and I have it like closed, so I think that makes it worse for like getting rid of the heat too. So like a desktop's really great because it's got like giant fans that are sucking in heat and stuff. And a buddy of mine had an extra 16 gigs of RAM that he gave to me. Hi, Johnny. And so I was like, oh, let me just take a look at this. And I had 2 extra spots in there. So I basically doubled my RAM for free, which is awesome. So I've now got 32 gigs in this box. So you'll see that like my compilation times are faster and things. That's even on like, this is a 1st gen Ryzen machine. It's not anything more. Yeah. Anders says gaming rigs often make for really nice development platforms. Yeah, for sure. And I think especially with streaming, because I have a GeForce 1080 and like that will handle all of this video stuff for me. So my CPU right now on OBS is like 2.6%, which is about what my MacBook Pro did, but that's not with like 2 HD feeds coming in and being merged into another HD feed. Brian B in YouTube also asks, there was a guy by the name of Tony D. He did Python stuff for Adafruit. What has happened to him? He's no longer working with Adafruit, and so therefore not streaming. But the last I saw, I haven't chatted with him since he left Adafruit, and he climbed Mount Rainier on his Instagram, which I thought was awesome, and that was something he wanted to do. So he's doing stuff that he's interested in, which is cool. Hi, Himesh. Yeah, so as I've said, like if you have questions, let me know. If any of my camera feeds pause, usually they pause kind of like right at the start after I plug them in, but I did right before I started, I had to like unplug them and plug them back in, which is unfortunate. So just let me know in the chats if I have problems like that. Okay, so I don't have my screen that I usually like to start with, and I'm over time, so let's get going. I will switch to my camera, and the cat camera is then down there. So hopefully this looks better. Hi, I'm Scott. I work for Adafruit on CircuitPython. Every Friday, normally on Fridays, I do these streams called Deep Dives, where we dive into kind of more technical topics surrounding CircuitPython and primarily the ESP32S2. Ivan's in the chat. Hi, Ivan. Thanks for making it. So I do these deep dives. They kind of like vary on topic with what I've been working on during the week. As we've been chatting here at the start for the first 10 minutes, we've been talking about my streaming setup and my development setup more generally. I switched from my MacBook Pro to my Linux desktop today or this week. It's been a process, let me tell you. There's certainly nice things about things just working that Linux doesn't always have. So I updated my BIOS and lost all my boot settings and had to do all that, but I figured it out, and we're up and running. So if there are any technical issues, just hang out and chill with me. But I think I cranked up OBS in terms of bitrate, so hopefully the stream actually looks better. As you can see, this way. He's actually this way to me. But you can see the cat in the window there. That is Spook. He's one of my two cats. He's the one with epilepsy, so he does have seizures from time to time. So just be aware that if he starts hissing or he does like a contortion, he's having a seizure, and I'll just take a pause while I watch that. And I'll try to remember to turn it off so you don't have to watch him do that either. But that's the heads up with the cat. Adafruit.com. So Adafruit pays me to work on CircuitPython and stream while I do it. So please, somebody has a cat with the same name. Billy Sheehan. Looks perfect. Oh yeah, he's got a great life, right? Like this is mostly what he does all day. He just lays in the window and looks cute. So no need to feel bad for him about that. So Adafruit.com, we're shipping. Please buy stuff, support us. They're cool enough to let me talk about the work that I'm working on. It's all open source hardware, open source software. And speaking of which, I think today is actually going to be more hardware than software. As you know, let's go to the overhead. So hopefully it's working still. Yep. So I have this. So this is a Sala. They're $8, and they're the development kit for, I don't know which way everything is. David, thank you. It says, I used to have a cat that had seizures, and it's very daunting to watch that. Yeah. Yeah, thank you. He's had them for like 5 years now, so we're getting pretty used to it, but it would be nice if he had fewer, for sure. Okay, so this is the Sala, and this is what you can buy for $8 off like DigiKey and stuff, which is an awesome development kit. It's pretty wide, and it's not feather form factor, and most of what we do at Adafruit is we like the feather form factor a lot. Here's another one that I just happen to have on my desk. It's a Feather NRF52840, just for comparison there. And so I think I've showed this off on the stream before, but what I did is I made a kind of like an adapter, and this is V2. So I got this from Osh Park, and this is their after dark service, so you can like literally see the copper, which is neat. I would pull it up. I'll pull it apart. I always bend pins when I pull it apart, but there you can see. So like that's the ground plane, and you can see that when I was laying it out, a lot of the wires went vertically. So I think today, so there was kind of one, I think on the blog post I said what I was going to do is start the native Wi-Fi API stuff. But I think that's actually not as interesting as what other things that we could do. And the reason that is because like I've already gone through that with like the bus IO stuff. So actually my plan today, I think, is the other thing that is kind of on my work queue is Lemore's starting to get ready to actually lay out some ESP boards, which is awesome. And what I wanted to do is like, this is kind of my test for like getting the pinouts right. And so when you're doing a new platform, understanding how all of the pins work can be really important. And kind of deciding what your stock pin layout is for things. And this is basically how I've been doing that is this adapter board, which is on OshPark, and it's also on GitHub if you do want to order your own. I think they're like $30 on OshPark. And then shipping is free. So it breaks out native USB, which is nice. What it has here is just like an LED. Yeah, Matt, it is public on OshPark. I'll pull it up in just a second here. There's a D13 LED in the middle here. And, oh, it's 1155 on OshPark. I'm way off. There's a Stemma QT connector. And then there's also a debug connector. It's not SWD, but it's like that form factor. So, yeah, let me pull it up. But one thing I want to do today, if I can manage to do it, is I actually want to modify this, and I want to do a V3. But before I do a V3, okay, so there's the OshPark link that Alvaro dumped in the Discord. So thank you, Alvaro, for that. I'll copy it and put it in the YouTube one as well. But I want to do a V3 today. So don't order this immediately. Because I actually do want to do a V3, and you can check my work. That's the risk, right? Like the risk is that if you order it, it's got a problem to it. And the reason I want to do V3 is I want to add a resistor and capacitor pair for the like 1-bit memory for doing the double click. And then I think I also want to add a reset button on here so that, oh, maybe we don't need it, right? So the way that this goes on, we don't actually need the reset button because the reset button is still available on the other side of the board. So I don't think I'll put a reset button. I'll just put the RC circuitry on there. But what I want to do before that is I actually want to test everything. Sorry, I don't know. I need to draw like a box on my desk of like where you can see and where you can't see. So I want to actually test this more completely than I have. The V2 is because I picked the wrong pins for I2C. And there is a URL on here, but let me warn you that URL doesn't actually do anything. I basically use it as like a design like identifier. And theoretically, I had that domain, so I can make those URLs. I'm just lazy. Maybe I should do like a redirect service. But yeah, I want to do a V3. But before I do that, I want to confirm that the I2C pins that I picked for this actually do work. And then I also want to I want to try to get a J-Link connection into the ESP. So if you've ever seen my guide that I did for GDB with at SamD and my workflow for when I'm working on things that really screw up the processor and I want like register state and things, what I'll do is, where's my metro? Basically, I'll take a metro. This is an airlift, but what? Where is everything? So on the metro, this is a Metro M4 airlift. So just ignore the fact that there's this thing here. Use a cutting mat. Yeah, to mark my boundaries. So usually there's a debug header here on the Metros, which is really convenient because we have the space. And so if Limor is going to design a Metro for the ESP32S2, it would be great to know that like what the pinout needs to be for this debug header as a backup. So it looks like Dan found an article about how to do this. I think it's possible to like connect via a J-Link or via OpenOCD or something. So that's what I'm thinking. So goals for today, we're 15 minutes in. One, I want to make sure the I2C works, which should be pretty straightforward using the Stemma QT connector. So that's why I have a couple Stemma QT samples here. And I'll probably just do an I2C scan. I don't need to, like, if I could do that, I'm confident in it. I'm going to need to install Kicad. I don't think I actually have Kicad installed on this yet. So I'll do that. And after I do that, then I want to dig into the debug connector and see if I can't get that working, because I haven't actually tested it. I think I have tested the UART pinout on this, but I could think about other feather wings that I might want to try with it just to make sure. So, oh, of course my cleaners are calling me right now. I'm streaming, I can't pick up. So the current pin mapping, those pin mapping, so anecdotal link to the Feather S2 pin mapping, and I started with that, but there were some that just didn't make sense. So let me get Kicad installed after. Let me install Kicad here. I think it's probably in here. Oh, it's already installed. Look at that. 516, it's the latest, so I should be able to just... You'll notice my like copy and paste is all off. Okay, so I have Kicad, but I don't actually have the repo yet, so I don't think. Oh, I do have some... Oh, you can't see me. Hold on. Desktop with overhead. Ah, look at that. Sorry. You're probably screaming at me right now. Okay, so Kicad's installed. I've got this PCBs directory. It's only got this one PCB in it, so I'm gonna need to figure out where. I think I published it online, so I should be able to just slurp it down off GitHub. So let me bring a new tab up. Ah, linear lasers are a nice way to mark camera boundaries. I'm a fan of Arch. It's the Linux distribution that I'm using. Okay, so here we see this is my repository for the Sala Feather. And it does look like I did update it. You can see that I've committed like the second version. So I'm just gonna copy this and clone. And I have like both Control C and sometimes it's Control C and sometimes it's Command C right now. Matt says OpenSCAD worked well for getting the CircuitPython on the... Yeah, it's not OpenSCAD, it's... I know what you're talking about. And I'm blanking on the name. But yeah, the Open... I'm like on their mailing list. Yasir asks, have you tried Manjaro? It's the same as Arch having a GUI. No, I have not. I have not tried Manjaro. I came from Gen 2 land long ago. What is it? It's open. I'm blanking. Open OCD. Thank you, Johnny. Open OCD. Yeah. And I think that's usually what you use with the ESP. But okay, so we've got it cloned, and now we just need to submodule init, because I have like Kicad lives, which is like a shared repo amongst designs. And now I should be able to open a project. And I'm like still learning all this. Open. All right. So here's the pin mapping. Kicad has been run for the first time using the new symbol library. Okay. This is what it's telling me. It's been a while since I've used it on. Like the recommended thing is grayed out. So I'll just do that. I tend not to use, oh dear. I swear I was on 5.6 before. Yippee, look at that. My OCD is very open. Oh, great. I don't know why that was commented out. Are there other is it because I don't have like a package? Does Arch Kicad. I'm used to the like all-in-one sort of thing. Let's see what this says. Build from source. I don't want to build from source. Ah, here we go. Kicad symbols. Anybody know? Is that why it didn't give me? So there's Kicad footprints, Kicad library. Lots of Kicad things. I just installed the giant one. Okay, so I think I want these other two as well. Oh, interesting. Convert your Kicad board into a nice looking 2D drawable suitable for pinout diagrams. That's pretty neat. All right. I always manage to get in the weeds, don't I? Is that what it was? Yeah. Download it all. Yeah, I was having audio problems on Twitch too. Yep, Mark, you're right, like always. It was because I didn't have the symbols. The problem is that I probably don't actually have the it won't give me the prompts, probably. But at least maybe the symbols will show up. Do I have that window open? I have too many windows stacked on top of each other. Okay, so what if I close this? They're installed now. Let's open it again. Oh no. Did I it didn't prompt me. Let's see if I can just close it all and reopen it. Ah. that you're right, Mark. Yeah, so Anecdata says each variant eventually needs a board, and CircuitPython boards, ESP boards. Right. Yeah. Yeah, I mean, boards, having different boards is pretty easy. And it means that you have like a good experience on each one. All right. Anybody know how we get the global? You know what? I wonder if I just delete this, delete that, then it will prompt me again. If I just delete the config library. One thing I missed from Linux is being able to put the RF at the end. And on Mac, you have to put the RF beforehand, which is silly. All right, well, it didn't remember what I opened, so clearly I removed something, which is fine. Hey, now it gave me that option. The recommended option's available now, which is good. Hey-o, look at that. Perfect. We have symbols, which is cool. So if folks haven't used, raise your hand if you haven't done PCB design. I know mostly I do software on here, but David's got a smattering of questions. David Stanton's on YouTube says, since you work for Adafruit, which is really cool, what is it like to work for Adafruit? And did you always work from home? Did you go into the Adafruit office before the pandemic? Let's see. What's it like? It's awesome. So my background is that I used to work for Google, and then I took a year off and like got into drone flight controller stuff, which is where the Chickadee Tech name came from. And I learned embedded software a bit there, and I also did a ton of PCB layout in Kicad, and kind of like learned my way into like proper PCB layout and stuff. I took like 2 EE classes because I'm technically like a computer engineer degree. So I could segue that into Eagle, but I basically started doing I did that for a year and was ready to find a job so I could make some more money again because I was basically just spending it. Nice. UTP216 says raise their hand to say they haven't done PCB layout stuff too. So this should be cool. So I basically I was going on show and tell and showing off the drone stuff that I was doing. And I went on there and said, I'm looking for a job. And they said, well, and the next day they emailed me and said, hey, we have an idea. Are you interested? And it was getting MicroPython working on their boards. And I'd used Python forever. I just had never heard of MicroPython. So it was like this perfect thing for me, which was amazing. So I've always worked remotely. So I'm in Seattle, and Adafruit's in New York. But it's amazing because I work directly with Lilmore and Phil, especially when we're getting starting. And now we have a whole team of people on CircuitPython. So that's been really great. And the setup has changed and grown a little bit. I've like swapped sides of the room, but I've worked from home for like 4 years now. 5 years if you count the year that I was working for myself. Yeah. Johnny's just keeping my hand down. So David Stanton, hopefully that answers your question. If you have more questions, feel free to ask them. Matt Lamb asks, is Kicad easier than Eagle? I've been using Eagle and have gotten to the point of feeling semi-competent. I've never actually used Eagle, so I can't actually answer that question. I recommend Kicad because it's open source and there's no like license fees or anything. So when I was going into my flight controller project and doing layout, I was explicitly thinking I was going to do it commercially, but I didn't want to have to pay pay any fees because I didn't really know whether I was going to make any money off it at all. So by having like Kicad, you know, 4 years ago now was like pretty mature and pretty usable. So it kind of just made sense as the option to use because it's freely available and open source. So I recommend Kicad because there's no restrictions on what you can do with the designs that you create. So that would be my recommendation. But you know, Lady Ada and Brian, who do most of or almost all of the layout for Adafruit, they use Eagle. So yeah, if you want to use Eagle, that's totally cool. But I'm a Kicad person, but I also like Adafruit doesn't pay me to do board design. Like I was talking to Lamar about this design actually, and she was like, "Oh, like send me the schematic, I'll make it because like these salas are pretty available." And she was just gonna remake it in Eagle rather than just using Kicad, and I was just like, like I wish that'd be the case, but. So yeah, I recommend Kicad, but if you're already into Eagle, that's totally cool. If you're not into any of them, like as I think it was, yeah, Johnny says it's not easier, it's just different. Yeah, I haven't tried them both, so I don't actually know, but I've been able to do whatever I need to do in Kicad. So I just recommend downloading the stable version. Like they've got some really cool stuff in 6, but the challenge with using the nightly builds is if you're going to share it with anyone else, getting in like the exact version the same is much more difficult. All right. Yeah, Bruce says it's great that they have such caliber working for them. Thank you. Yeah, they because they allow people to work remote, they're able to hire really good people, which is why more places should allow remote workers, because you can basically pull from the whole world, which is great. So Trombley on Twitter asks, what is this circuit for? So if you see here, this is actually exactly this circuit. So what it is it's an adapter between a Sala dev board like this and giving it a pinout of a feather like this board. I have so much trouble like moving everything with everyone. Okay, so that's what we're doing, and our first task is actually to test the things that we have not tested. Yeah, Unexpected Maker says more S2, yay. Yeah, I was going to do some S2 stuff anyway. I've been working on the ESP32 SPI networking libraries, and I need to finish those, but I wanted to get the networking stuff. I think I have enough information to get the networking on the S2 going as well, and then I can continue to like get everything polished up and out the door. But we're about to start laying out hardware, I think, and by we I mean Lamore. So she likes to know like exactly like which pins we recommend for everything. So I'm gonna try to do some more testing on this version, and then I want to add a V3 that just has the resistor and capacitor spots, basically, so that we can do the double tap magic as well. So first and foremost, let's just get CircuitPython on one of these. I don't know, so I've got two Salas here. They probably both have CircuitPython, but neither of them has the absolute latest. If you haven't been following along, Hierophect, Lucian has actually started helping me out with it as well, so that has been awesome. And he just added PWM support, so I guess we could actually start by just trying that. So I'm just gonna stick these two together, and I'm still showing the desktop, and I need to find... I have too many cables. I might actually need a longer Or scooch my USB hub a little closer. Metro can go away. So I'm going to plug, this is just a short one. This is not the USB cable that I always forget to turn on. So I'm just going to do the short one into like the debug port on the Sala. And then this is the one, if you haven't seen it, if you're new, this is a cable I got from my time at Google actually. But if it's green, the cable is data only. If I click the button, then it's like orange / yellow. That means the data lines are actually connected. So it's really nice for testing if you think the USB is going to have a problem. So I actually haven't actually used this stuff yet on my Linux box. I've installed it and compiled it, but we might end up just debugging that as well today. So let's do a new tab, and you can see what I'm doing. Ports. One of the side effects of this stuff is Arch has GCC 10 in it. It's the one that's installed by default, and so I went through and cleaned up a bunch of stuff to get CircuitPython building with GCC 10. And that's really cool because it also looks like it's the output is more compact. So we're gonna gain like, it looks like about 1200 bytes on every board, which is awesome, especially if you've used it. You've seen that we like are very tight on some of the boards. So that's cool. To test the things we have not tested. Yeah, I'm really bad at testing. Lamora is really good at testing. Check out Adafruit main. Git status. Submodule. Oh, you know what? I forgot to... I did a release, but I have not announced it yet. I forgot to do the blog post and the forum posts, so I need to do that. At MelSamD peripherals, I shouldn't care about. I'll just ignore that. I had to update. Actually, the Proto-Mentor one does not have to do with me. Mark says I did one PCB and had one bad trace. I think that makes me an expert. With my flight controllers, I had like some that had like 5 revs. I had 1 rev of like my very first like microcontroller board I did for the flight controllers. I forgot to break out the SWD pins, so I had no way to like do the initial code load, which was unexpected. Kralian says, classic. I have too many cables, immediately followed by I need more cables. And Unexpected Maker says, hey, we can't see the bottom of your terminal, so I'll help you with that. I had too many of the wrong cable. And then Fetty2 says, GCC 10 has a ton of optimizations. I'm curious in running a benchmark without changing anything to see if there are unexpected speedups. Yeah. Oh, and Alvaro's so awesome. Can everybody just give Alvaro a shout out? So there's somebody jumping in the chat who asked what we're doing in Spanish, and Alvaro just replied in Spanish, letting them know what's happening, which is amazing. And Alvaro's also authored and translated a bunch of our CircuitPython guides to Spanish as well. So thank you so much for that. Yasir asks, do you do the unit testing for CircuitPython? So we have a lot of unit tests that we've inherited from MicroPython for the core of the Python stuff. And we don't break those. We make sure they stay up to date. And occasionally we add to them, but generally we just leave them be. We do not do a ton of unit testing, largely because for like the hardware APIs, because they would take actual like hardware connectivity and stuff, which is it's a tough problem. Okay. So I think that which one did I pick? It doesn't matter at all, actually. And it's not, I need to activate the boards as well. I think it was the room. We don't use the external PS RAM yet anyway, so it doesn't matter at all. This is probably gonna be unhappy. But I think if I... No, I don't want to activate that. I want a source or... export. I did install it. Huh. There we go. All right, now we should be set up to build. Yeah, am I humming? I'm in choir, and I haven't gone to choir in a long time because that was one of the first things to go with the pandemic. So I'm definitely a hummer. You can keep me distracted by asking me questions. Otherwise, I'll keep humming. Uh-oh. Oh no. That's not good. I mean, just clean and try again. Otherwise, we might end up debugging the ESP. So how's this new setup working for people? Is the quality better? The audio should be the same. Oh, and you can't see me. I can switch to that. Hey, there we go. The clean worked. Johnny says I do karaoke instead. Nice. I like singing with a group of people. What type of choir? It's like, you know, it's a community choir, like 50 or 60 people. We were supposed to do what we were working on when we quit was like St. Matthew's Passion, which is a big... David says, I'm happy with the new setup. Awesome. Bruce says, I'm on my desktop today. Too many distractions. The Make J13 is way better. Yes, but you know what? It's like J17 on my Mac, and it still doesn't take as much time. Why so many steps to get an S2 port ready to build? I think it's just because of getting the ESP IDF toolchain set up. Because it's not set up by default. Bruce shows his monitors. He's got more monitors than me. I just have the one ultra wide, which I really like. Okay. So we should be able to just flash it. Except I'm on Linux now. And I think it's ACM something. What? Ah. It's been so long. I think that this will work. I think somebody added that. ACM0. There we go. Bruce says, I guess I could set up the build environment here for CircuitPython. Yeah, Kralian is from a Mac. I'm coming from a Mac. I'm guilty as charged. Anecdata says you have some ideas already for remapping pins. IO26 may be my error. It's a pull-up, but I can't seem to drive it low. 6 and 7 are ADC1 and could be good to expose. David says the sound is slightly out of sync with the video on YouTube. Did that just happen when I started compiling? That can happen. Yeah. Mark says the only thing wrong with the new setup is your main cam sometimes autofocuses when it shouldn't. Yeah, and in fact, this main cam is like 6 years old. It's like an old Sony that I had laying around. So the new ones would be better. I can also look into settings for next time and not have it on autofocus at all. But I do kind of like being able to hold stuff up and get it to change focus. So I know it's a little weird when it does a like really dramatic seek, but sorry. Do I have to put it into... Uh-oh. My keyboard's not working. Oh! My keyboard is a USB device. I think I might have just... I think I tried to connect to my keyboard instead of... Maybe I accidentally just flashed ESP code onto my keyboard. Hey, it's back. LS USB. Keyboard. Okay, so ACM0 is my keyboard, not my... okay. It's USB 0. I just tried to flash my keyboard. Hey, there we go. Johnny posted a picture of his setup. Yeah, I could try to get the audio synced up perfectly, but it's kind of hard. I've got like the Blue Yeti going down. Plus this camera, the reason I switched was I got a Magewell, which is a HDMI to USB converter. So I'm able to use this like actual like proper point, like a fancy Sony point and shoot with HDMI out. But you also probably notice like the black box this way. It's because it's like old enough that it's a 4x3 camera or something like that, not 16:9. All right, we're loaded up. Let's click in and see if we get CircuitPython, which we should. Looks like we did. So we've got some stuff on there. And we can screen to it. Mark says my desk is too... Mark Gambler says my desk is too messy to post. Oh no, I'm out of water. We're 45 minutes in. All right. What is this current code doing? All right, so this is UART test code. So let's just rename that. I wonder if I actually use that because I've got a GPS feather wing on my desk that I put away. Nice. Johnny says the Swedish translation of CircuitPython and Weblate is at 100% again. The never-ending story. Yeah, we keep adding. Oh, good. David says the audio and video are back in sync. Might have been when I was compiling. I think that's pretty typical. So I2C test here is the BME 680. So that is not one I have. That's just a breakout, not a quick connector. And I kind of just want to try the quick connector. So let's just take the one I've got. And can you see the overhead? You cannot. Let's go to the overhead. Go to the overhead. So if you haven't seen it, Stemma is really awesome form factor that we modeled after the Quick system from SparkFun. So it's this like tiny plug of 4 wires, and it's just power, ground, and I2C. And just connecting that. So this is a, what's it say? LSM6DS33. It's just like some random Stemma thing I had on my desk. So let's just see if we can't get this working. New text file. code.py. And we'll open it up. And oh, you can't see my screen. Sorry. Gonna do import bus.io and then bus.io I2C equals bus.io. And this is the problem, is that I haven't created a like library for the adapter, so I have to look up the pin mapping every time. For.io and oh, but you know what? I can look on this other file. Too many windows open, and well, not the right ones. So I'm just opening that I2C test back up so that I can crib all this. Ugh. Once again, like the KDE apps are Command C and Command V, but it's Control S for saving. Oh, and it didn't find anything. That's not good, but let's double check that those are the right pins. And they're not, so SDA is now 1. And look, we found 6A. So it looks like it's working, which is awesome. I know Jerry was pretty sad. He got one of these adapter boards and was pretty sad that it didn't work. So that's the easy part. I'm going to assume that because that works, that I2C works, which is maybe not the best thing, but I'm kind of lazy. So let's move on. Let's take a crack at, I don't know if, I know Ivan said hello earlier. So I don't know if Ivan's still in the chats, but I would love to, yeah. Mark says, Tanuk changed the hotkeys for Kicad. I gotta change the hotkeys for everything, or I've just gotta give up and change the my search for 6A. I think it's right. Like this is the output here. Charles Bukowski on Twitch asks, "Is this MicroPython?" This is not MicroPython. This is a MicroPython family. It's CircuitPython, which is based on MicroPython. So, kind of. It's not proper MicroPython. but CircuitPython runs on the ESP32S2. Okay, let's find ESP32J-Link. Why? Don't want it to be gigantic. ESP32J-Link. Has anybody done this already? Used the JTAG connection? Successful connection of Segger J-Link for JTAG use. Ooh, instructions. How do you get the Segger to work for OpenOCD here? What is the target value for step 3.3? Why did you do that step? If you change that line to J-Link interface, it should work. It's 2 years old and it's for the regular ESP, but it should be possible. And there's a command line. Bruce says I used it on Windows last year sometime, J-Link that is. Did you use it with ESP? Charles asked, does CircuitPython run on the regular ESP32? It does not, because we only support boards with native USB now. Because so much of the process of CircuitPython is like you plug it in, you get a drive, you can edit stuff. So boards like the ESP32 or chips like the ESP32 aren't able to do that, and therefore we don't support them. Okay. So this looks like what we want. Yay. It must be somewhere else now. Okay, let's quit that. Do we have open OCD now? Looks like we do. All right, so that is from within the tools. So what I'm gonna do is let me go to the overhead. So I've got this, it's got my adapter on it. I'm gonna disconnect the stemma stuff just because I don't need it. That's not what I'm doing. And then I've got, oh, come on, hovercam. I've got a J-Link. Maybe if I hold it, there we go. So I've got a J-Link base here, and it's got an adapter from the giant connector to a smaller, like SWD style connector. But it does have, come on, you got this. Oh, come on. There we go. So it's got both SWD pinouts and JTAG pinouts. And if you notice, the SWD pinout also has like the JTAG names. So that's what I did it based on. Yeah. So Bruce says I did do it with ESP32 using an espresso board. Perfect. I will ask you about this then. So theoretically, if I picked the right pins, I should be able to just plug this into here, and hopefully it won't smoke or anything. This is the first time I've actually even just plugged it in. Hopefully it's oriented the right way. Sorry you can't see anything, but voila. So now we're plugged in. And now we need to see if we can't get this J-Link thing going. But hopefully... Is this what... here we go. Docs.expressive. JTAG debugging. Let's go through here. You know I like to read the docs. And of course, I'll switch it over. So this is JTAG debugging. It's on the official Espressive programming guide. So let's take a perusal through here. Has ported OpenOCD to support the ESP32 processor and the multi-core FreeRTOS. How it works is you have your GDB, which talks to OpenOCD, which talks through a JTAG adapter to the ESP. And then you can use the normal ESP tool loading interface. Quickest and most convenient ways to use their ESP32 Rover kit. But there's a bunch of debug adapters, which the J-Link is one, I believe. So the version looks good. You may also verify that OpenOCD knows where its configuration scripts are by printing the value of OpenOCD scripts environment variable. Echo. All right, so we have that. Configuring the target. I don't know what my options are. So maybe if we... Man, it's getting hot in here. Scripts / board. And ESP. Doesn't look like it's under the boards at all. There's no Sala here, so I mean that makes kind of sense. So maybe if we go look under chip, no. Do you happen to have a DigiKey part number for the JTAG connector you have on the adapter? You mean this one that's nice and short and isn't super wide? I don't know if DigiKey carries it, but I asked Lamore about it, and we carry it at Adafruit because of that. I think that's what you're asking about. Actually, I need to add some more to my cart. That was the last one. So I'll just do that right now. So it's not this box header, it's this mini SWD pitch connector. Looks like they're in stock too. So that'll be good. But yeah, I don't think you can get them from DigiKey. I think you can only get them from Adafruit. For a while, 1-Bit Squared carried them as well, but they were kind of pricey as well. So, but yeah, they're really nice because they take less space. Okay. CPU. ARM. What? Board. ESP. Let's just see what is in here. Hi, Thomas from Twitter. Target. ESP32S2. Nice. So I haven't used OpenOCD. So we just do target ESP32S2.cfg. And then do we also have to do one for the adapter? Oh, nice. Mark gave the DigiKey link to that product I showed on Adafruit. Yeah, it's a cool adapter. I like it. And then Sorry. Then the J-Link side is in. How do I tell it it's a J-Link? Interface. Huh? Am I backwards? Do I have to do the J-Link first? Does order matter? I should really modify that guide. Actually, I should do that because it's old. Hey, that went slightly further. An adapter speed is not selected in the init script. Insert a call to adapter kilohertz or JTAG RCLK to proceed. And then Mouser has it too. So how does that work? So here's an example where it has adapter kilohertz. Is there a way to do that from the command line? Does anybody know? I mean, I'll be pretty happy just like the I2C. Like if I could just get it to connect and act like it's working, that's enough for me. I'm gonna open the window. It's hot in here. Kitty. I thought they were gonna like make a bunch of noise. As you may know, they've been doing construction across the street for a new house. They're almost done, but they've got to like dig the street up right in front of our driveway so that they can lay power lines underneath. So tomorrow or next week's going to be really crazy. Okay, so maybe I just edit that file. Debug. Oh no, I hope it's not 6 weeks that our driveway's dug up. I think it's gonna take them longer to actually get the like driveway part redone, but we should be able to use it. But the problem is we have some raised beds between the like power pole and our driveway, and they think they might have to basically dig underneath the raised beds, like where the raised beds are, to place it. So we're like crossing our fingers that they'll do it right next to them, but not below them. Otherwise, we're gonna have plants that are not gonna be happy. So close. What am I missing? I feel like one of these tabs has the example that folks used. Yeah, it was sewer work. Ah, that makes sense. I could probably just add another file to set that. Oh, here. What C is command? So maybe I can do C adapter. What was it? What's it complaining about? KHZ. That's probably not going to work, is it? Oh, look at that. Yes, it worked. All right, well, now I'm curious. Let's see if we can't actually keep going. So that's how to upload. But now we want to do the debugger. And I want to do it command line wise. Ah, there you go. Time lapse of digging a hole for Mark Gambler. On launching a debugger, you'll need to provide a couple of configuration parameters and commands for GDB init. Oh, I'll do that later. Okay, let's open a new tab. I'm pretty excited about this. I like do use it from time to time. So we want to do extensa. Oh, and I'm in a different. So let's do extensa. And there's no E. Tab. What? Oh, it didn't work, that's why. Okay. S2 elf GDB. Do they have a Pi version? No. I like how it turns like bold white when it matches. Don't have a GDB in it, but that's fine. And we're in the room and firmware.elf. Oh, it looks like I have a GDB already set up. GDB init, that's not going to work because it's OpenOCD providing the GDB server. So now I'm just, oh, you can't see them. I'm copying these commands right here. So, no, I don't want a giant. So we are connected. Ooh, let me disconnect my USB because my USB won't be happy. Set remote hardware watch point. Again, like I'm just testing this to make sure it works. Come on, reset. Halt. Cool. Flush regs. What do you think THB at main is? I don't know what that means. Hardware breakpoint. Continue. What is THB? Thread? Thread hardware breakpoint, maybe? Thank you. Alvaro says maybe for letter, system settings, desktop screen edges, maximize windows by dragging them to the top of the screen. Turn it off. Ah, okay. Help. Temporary. Thank you, David. Like HBreak, except the breakpoint is only temporary, so it will be deleted when hit. Oh, I didn't know that. I've never used temporary breakpoints. So, right. On reset, continue. Cannot execute this command without a live thread selected thread. On reset, halt. Flush regs. Yeah, thank you, Mark. It's a one-time breakpoint. It seems so. I'm used to leaving them in there. Does it tell me how to... I've never done this like RTOS multi-threaded stuff. I don't know actually that I built in debug mode either. Yeah, Mark says the chat latency is pretty bad. That's all right. You're still being helpful. Okay, so I don't know how to continue. Current thread has terminated. Info threads. Let's do that. Current thread ID 1 has terminated. That'll do it. Set the current thread's name. How do I select a thread? Thread 2? Ah, continue. What is happening? Now there are no threads. On reset, halt. Continue. Curlian says, yeah, I think we're 30 seconds off or more. It takes ages to show up on YouTube. That's what the Discord chat. Well, are we convinced that the hardware works? I don't know how to use GDB with threads, but like I would think that reset would reset everything, including the threads. But I don't. Right, and this shows that I can't load. I don't load over it, which is usually what I do. I don't want to use Eclipse. What did it say when it loaded the file? Like it was able to set a breakpoint. Let's just see if we're able to break at reset into safe mode. Which I think, yeah. So it has some notion of like what. I don't know. How do I start back up? Like it did mon reset. I'm so used to just like mon reset and then continue. Nobody has any idea. Interesting, there's like custom ESP32S2 stuff. That's kind of neat. Yeah, I did iThreads, and I didn't have any threads active. I guess there is one. Now there's no threads. Threading's complicated. All this fanciness. All right, well, I'm convinced the hardware works, which is the question that we're really answering today. And we have 40 minutes or so. And I think it would be kind of cool to do some PCB stuff. It's going to be very simple, right? Because we're just adding a resistor and a capacitor. But I think it would be neat to take a look at that. So are we, as a group, actually maybe we should test Pulse.io. So let's delete this or shut this down. Let's just do a Pulse.io real quick on the LED, which I set the remote hardware watch point limit. I did do that. You have to flush regs every time. Oh dear, I already quit. I'm sorry, I'm gonna move on. I'm convinced the hardware works. Just pull that. Disconnected. And I'm just gonna like hit the reset button. And then once I reset, I want to turn on the USB again. Mark says he was shouting silently at me to not close the window, but it was so slow. It came too late. Sorry. I know, Mark, you're always getting things right for me. Okay, let's do screen ACM1 for CircuitPython. And this is cool to see that this error works, which is meant to like help people know that they need something plugged in. So let's just gonna rename it again. This is very much my workflow. Where what I'll do is I'll like rename the examples. So this will be like ice-grid-ski sand. And now I'll create a new file, which is nice. Mac doesn't let you just create a new file. And we have a new code.py. Kate might be confused. So let me close that. I like Kate, but it was doing some weird things where I was trying to like leave the file open, which I like to do even though like I disconnect CircuitPython. I like to have the like copies of the files local still. So let's just do import Pulse.io, if I can spell, and import board. And let's do p equals Pulse.io dot pwm out. Board dot something. And let me switch away from my face to the overhead, and you should be able to see the red LED. I didn't test it, so the LED could be on backwards as well. So that's something to be aware of. But it's on D13, which is IO34. And I think duty cycle 2 to the 15. And let's, before I save, let's get that on the side. Let's see what happens. Ah, did the light blink at all? It wasn't blinking. Have it Sleep for 2 minutes. Hey, look at that. The light is red. So now if I do this like 2 to the 10 and hit save, it should get dimmer. Did it get dimmer? Oh, you know what I should do? Actually, let's just make it. It doesn't look like it's getting dimmer. It's certainly on, which is great. Are we actually interrupting the sleep here? I can't tell. Hello. Yeah, see, we're not. Which is why it's still on. That's a bug. We can't control C it either. Can we not interrupt sleep on this? Rob House says beans. That is kind of how I feel about that. If I gotta wait 2 minutes for it to finish. I should have done like 10 seconds. I'll even. But Control C's not working? That's so unfortunate. It's not Command C. Oh, maybe it's because of the. Oh, I said it as copy. Oh. Wait, no, like copy's now meta C. So Control C should be. Hey, there we go. Soft reboot. Now we have a hello. It still looks pretty bright. Oh, but it's to the 15. I think it's getting brighter. Maybe I have it inverted. Oh, what? Was it just like really slow to process those? It's working really well. All right, so it looks like it is inverted, which makes sense. I think I hooked it up so that the LED's on the low end. So it's off there. And then if I do like 0.1, it should be pretty bright. Really? Our sleep, it doesn't interrupt sleep with the reload? Can't convert float to int. Yeah, well. I can convert a float to int. Johnny says, woohoo! LED works, which is great. I put it on the right way. That's usually the reason the LED doesn't work. And that does look brighter. So cool. Okay, so we've tested the JTAG. We've tested the Stemma QT connector. I haven't. If I was good, I would test all the pins, but I'm not that good. So let's, in the next half hour, let's do the V3, and we can order it from Oshpark. It actually shouldn't even take a half hour. So what we need, here's the schematic for the breakout board. And what we want to do is we want to add the 1-bit circuit. So when you double tap, we need to basically, when we start up, we need to know whether you just were running. And so the way that we do that is we basically store a bit high. If the bit is high, that means that we want to stay in the bootloader. So it's really a simple circuit. It's a capacitor, C small, that it by default is not charged up. And then what sets that default value is the resistor, which I also just want a small one. And I don't use the US version. So I'm going to just move that there. And they are both to ground. Don't hate me for my schematic. Style. Oops. Oh. I want X to mean placing a wire. And then these are connected as well. And so now we've got to figure out what pin we want them to connect to. So this is a little hairy. But I think if I thought it would highlight it for me. If I clicked IO4, I thought IO4 would show up. But basically I need to figure out which of these pins I'm not using and ideally use so these inner two, so these are like the pin connectors. The inner two are the ones that I use for the feather, and then the outside ones are from the Sala. So I want to figure out I want to ideally find one that I'm not using. Like, it looks like IO16. So if I just look here, like 17 is a 0, and 15 is a ref. 14 is also unused. 13. And then if we look at the... Yeah, Unexpected Maker says you originally wanted IO16, didn't you? I think that... Where did I put that board? So I tested this with... I think you're right, Sion. I think that I made a little breakout that would just stick on here. Like, it would just stick on the board itself. And I think I did have it spaced, so it was 16. Yeah. Can you see the overhead? Yes, you can. So I know it's maybe a little small, but here it's like ground, 5 volts, 17, and 16. And I had a thing that would just stick on those 4 and connect ground to 16. So yeah, I think let's just pick 16. There's one other thing I want to check on the data sheet, but I will. I could do that in just a bit. So I'm going to hit C for copy, and I should figure out how to make that nice. Boy, bam. Okay. And then I think the values I did were 1 UF, and the R managed to be 100K was enough for me, but it's like really 100K plus. So what happens is that on startup, the resistor kind of keeps it the same as ground, right? Because any leftover charge on the capacitor can drain out through the resistor over time. But so the resistor value dictates how slowly that charge leaks out of the capacitor, ignoring the fact that the capacitor also has like parallel resistance or whatever. So what happens is, so Unexpected Maker asks, will you make the pin in CircuitPython be settable at the board level? Not in CircuitPython, but in the bootloader, I think. Yeah. It's actually in the second stage of the ESP bootloader that does this stuff, though. So, like, it's not CircuitPython that actually sets this pin. But it's like it's a pin that we wouldn't want to expose for anything else. Because you'll have this capacitor and resistor on it, so it would be hard to like make it do what you want. So IO16, And let's just set our footprints. We're going to give it a... So it's telling me something else. I don't know why. It is loading footprints. The progress bar is almost done, and now it's telling me elapsed time. Alvaro's breadboarding it. Where did I put... I just had it. I'll show you what I used. If you've looked at my Oshpark, I basically made this pull-up helper board. I think it's in here. I just put away a bunch of boards and now I'm taking them all out. It might be in the other room. Too many dev boards for days. I'll just show you on my Oshpark. Yeah, so Unexpected Maker says, I can't use IO16, but I'd like to add this functionality in a future revision, so being able to set it for each port would be great. That's a great segue. Let's talk about the requirements for that pin. So let's just pull up the data sheet. And of course I looked for the regular one. And what I want to look at is the thing at the end, which is the pin state. This is going to be kind of small for you, I think. Really? I'm definitely going to turn that off after the stream. All right, I think that's pretty good. Let me zoom in a little bit more. The hope that you can read it. So this is the pins, the name of the pin, the power domain, all the different functions that can connect to it, and then what it is at reset. And this is the thing that matters the most, I believe. That basically, because we have that external resistor, which is a pulled down resistor because it's connected to ground, we want to make sure that we're not competing with anything that's a pull up. So this is an example here of the WPU after reset or at reset. So you can see that like these are all the flash ones. They have pull-ups. GPIO 0 is a bootstrapping pin, which means it's read immediately at startup and dictates like some of the startup code's behavior. So we don't want to use that. We don't want to use any of these that have these other pull-ups. And we don't want to use the UARTs because they have pull-ups. 45 is a pull down, and 46 is a pull down as well. So we don't want to use any of those for this. And in fact, this is the error that I made that you probably saw me make on the first revision of this breakout board, was I actually used 45 and 46, I think, for the I2C. And that's a bad idea because I was basically overriding these pull downs and they were making them pull ups, and it was bad news. So I think that any pin that is just off, doesn't have any sort of pull up on reset, should be fine. Because there is like, when you're resetting, right, when you're double tapping, if you're down on the button for reset, like the ESP is completely off, and at that point, like something's going to happen to the capacitor that's storing that like 1 bit of like, hey, we were just on. And so we want to make sure that that capacitor state isn't interfered with by like the default state of the pin. Because there is a like, even once you lift up off the reset and the chip starts up, like there's a duration between when the chip starts up and when it gets to the point where the thing that's deciding whether to go into the bootloader reads that bit back. So I think any pin that doesn't have a pull up or a pull down should work for this technique. Right, and it looks like GPIO 16 is actually a crystal pin, which is why it's a bad idea. So, you know, what we could also do is we could actually add multiple spots on this breakout board to do this, because, yeah, we could do that too. So let's see, are there any others? What am I in the middle of? So we looked at that. I was gonna, oh, I'm gonna log in. Log me in. And what is that? I don't know what that's telling me. My projects. So here you can see V1 and V2 of the adapter, the flip dip stuff. So this is what I used for just mocking it out. Basically, I put the ground here, and then I took these ladder two, put the capacitor on one, the resistor on the other, and just tied the two together to connect them. Right. Unexpected Maker says I can't use 16 or 17 because they are for the external crystal. Yeah, that's a good point. So maybe let's not use 16. Like, if we want to, like, now is a very pivotal time for this chip because, like, Unexpected Maker is still very early on in creating hardware for it. Adafruit hasn't actually laid out any hardware for it. So, like, you can, by choosing these pins, you can kind of become, like, the de facto standard in kind of the same way that, like, the modules from Espressif are, like, very widely used. It's not impossible to use something else, but, like, most people will just copy another design and what they're doing. So let's take a look, and let's not use IO16. We can't use, like, 17 is an A pin, an analog out pin, I think. So we don't want to use that either. I mean, we're already hooking it up to A0. So 16 we could use, but like 14, 13, and 12 are all unused as well, I think. 12 is used for D6. But 13 and 14 are unused. Yeah, Unexpected is ahead of us. Nice. Starts production on the Feather S2 next week. That's amazing. Are they going to ship with CircuitPython? They should. CircuitPython is the only thing you could ship with that is actually, like, useful to have on already. Because with Arduino, you've got to flash it regardless. Okay, so let's just double check 13 and 14 here. So 13 and 14 look okay. They're ADC inputs and touch inputs. And they have this, like, external wide SPI flash, the secondary SPI flash, but they don't have any pull-ups and stuff. So they should be okay, I think. So let's not actually use 16. Let's use 14. And if the layout's bad, we can change it again. So let's save and do update PCB from schematic. Yes, I would like to enable acceleration. No footprint assigned. Okay, that's fine. I think I have the window open because I was doing it. But I've got, like, stacks upon stacks of windows in, like, the corner of my screen that you could see. Yeah, Unexpected Maker says, yes, I want to ship CircuitPython on by default. Yeah, we should fix that reload problem. But yeah, shipping with CircuitPython is, like, very valuable for CircuitPython. Okay, so for the footprints, I like to use the hand soldered ones because I'm, like, making a board that most people will hand solder, including myself. And these fonts are actually quite large. And it's kind of slow. But we're going to go through here, and we're going to select resistor SMT. I do 0603. And I think that it's telling me it's the hand solder version. positive. Oh, come on. Yeah, it's the hand solder version. So we're going to want that for the resistor. And then we're going to do the same thing for the capacitor. So this is basically like correlating your schematic vague picture of what you want to like the physical like manifestation of the copper on the board. So, okay. Update from schematic. And now we've got two more here. And we could place them right where the chickadee is. So there's a couple things to think about in terms of placement. I should just get rid of that bar. So here's the pin that we want to associate with. And so we're going to want to be on the red side. So what we're doing is we're looking at the board from the top down. So if we actually compare it to here, like you can see the chickadee and like the copper wires you can see here are the ones in red on Kicad. And then the green ones are the ones on the flip side. So I think what I want to do is I want to place these. I think what I'll do is I'll snake out here and just move these two vias. So a via is a drill through the fiberglass that takes a signal from one side to the other. And my grid is like way too good. So I think what I'll do is I'll just take this and move it and flip it. And this one too. It's like clarifying. And they don't need to be super close together. I like where the chickadee is. So I can just fit them above the chickadee. I could nudge the chickadee down a little bit, actually. This is my logo that I drew. I kind of like making it sit on things. But then again, it's also like exposed copper. So it's also good not to have it like right next to a pad, because then you'll get solder on it when you hand solder. Okay, so that's there. And then, you know, IO13 is right here as well. It might be easier to run IO13 out rather than 14. Because of where we chose to place these. So I'm just gonna hit X to get in wire mode and then D to drag. And now I can just like drag these down just a smidge. Kind of getting ahead of the game in terms of coming out. And one thing I'm also looking for is this blue here. That's silkscreen, which is like the white lettering on the board itself. And ideally, you can put holes underneath that, but it generally like basically makes the white have a hole in it as well. So it makes it kind of ugly. So I'm going to save this. I'm just going to go back to the schematic and use 13 instead of 14 just to, because I can. Like 13 doesn't go anywhere, and we can see that 13 doesn't go anywhere because there's no wires to it. Hopefully it's not anything special on the cell either. Okay, and I hit X for wire mode, which I was already in, like that, and just run it there and run that there. And we need it grounded. So what I'm actually going to do for ground is like this whole thing is ground here. Either I could move this via to the right and then it could fill all the way here. But I like my chickadee on the black background. I could run ground over as well, but I think what I'll do is I'll just do a via because there's ground on the other side. So I'll just do a via here and escape via. Whoop. So I just like added a view there, and I'm gonna connect it back up. And now you can see the white wires that were there are not there anymore. So now I'm gonna do, I like the 3D viewer. So let me drag. So it's got the wrong colors, but I really like the 3D view in Kicad. It's a great way to like visualize what it's gonna look like. Johnny says, yeah, silkscreen looks more important than functionality. I mean, I've got a lot of room to play with, so it doesn't really matter. And what I also did is this board is so bare that I think I'll just turn off these designators. So like the C1 and the R2 are just like, if you're putting a lot of different values everywhere, it can be helpful. But if you look at this is the LED, the D13 LED, and then this is the resistor for it. Like, I didn't actually label it because there was, at the time, only one resistor on the whole board. So, like, it's so simple, it's fine. And I'm going to do that here, too, I think, because they're unique position. I could change it to purple, and I think I will order it in purple as well as After Dark. Osh Park's great, and they're close to me. So what? Hit escape to. So I hit the reference and I changed it to visible or unchecked visible. And then I also want to edit this because this is now no longer V2, it's V3. Can anybody think of anything else that I should change? And add ray tracing. Did I close the 3D view? I did. So now this is up to date. It has all of the labels for the feather, and then it has some of the labels for the Sala. Lamore wanted this to be a USB-C, but USB-C is harder to... Teddy2 asks, what would happen on a feather to the pins that now go to the serial programmer? That's a good question. I think that I would break them out. So either use them on the feather itself. You could use them as TX RX, but that might be a little funny. So I don't know. That's a good question. In this case, I'm not using them. TX and RX here are different than the ones that go to the serial programmer. I think I made TX and RX here the UART test ray tracing. My graphics card is just gonna be ray tracing. Ooh. That does look pretty pretty. Why don't they just have an Osh Park mode? Can I set? I think I could turn off silkscreen. I don't know. Miso and Mosi. We're not changing the name. We're just changing what it means. I definitely do not like SDI and SDO. Like, some people were critical of that, and I agree with that. I think it's, if anything, I would do it copy and copy or whatever, or SIPO. Everybody wants castellated, but not necessary here. That ray trace looks nice. We need default settings for Osh Park for colors. That's what I think. Because it definitely does not look like the overhead. But it's great. Like, this view is great for How do I turn it off? This view is great to just make sure that nothing's, like your silk screen is not being hit by anything else, and visualizing like the placement. So there's nothing on the back. We could put an Easter egg on the back, but maybe we could label these two. Let's just take a look at that. Okay, we can close this. Hopi and Hippo. Yeah. What was I gonna do? Where should I put a text thing that says JTAG? JTAG. Just there. And then maybe a stemma. Here. Like, get the drill hit right around it. Is that centered? If only I had a view. Ah. Mark's got his settings. How does that stemma look? That stemma label doesn't look too bad. It looks a little funny that like the JTAG's further away than the stemma one is. But I think it's okay. I mean, maybe we can... Oh, you know what? We could move this ground via... Just drag that right there. I love my... I hate it when there's a kink. That's better. That's pretty close. Maybe we want to move the JTAG a little bit closer too. This is where I pretend to be a designer, like a graphics designer, even though Mark's a much better person to do that than I am. I'm a little worried that like, I guess the box doesn't go over that. Okay. Enough fussing. Anything else that should go on there? Unexpected maker renamed to SDI and SDO. That's fair. I think on most feathers, it's actually MI and MO. Which I guess is not much better than SDI and SDO. All right. Last thing, we're going to see how it looks. Mark thinks that the problem with putting it there is that if you put one with the box on, then you won't be able to see it unless I put it like way far away, right? Because like some of these connectors have the, like the big box. I don't want to do that. Got to think about the box. And I'm just eyeballing it. Like 3 people are going to have this anyway. All right. Oh, it's a little off center. I do like to pretend to be a designer. Okay, sweet. So V3 adds the capacitor and resistor for the double click. And we tested JTAG. We tested the stemma. We tested the USB. Nobody had any other ideas in terms of what we should add to this. There's somebody in Twitch asking if you want to be famous. Designing for the masses, exactly. Yes, but Lamore is more like probably going to use this as a base reference for the like feather mapping, which I really should like test feather wings, but maybe she'll just order this and like she can test all the feather wings and decide that I made bad choices. Cool. Mark Olson says, I might add some of these to my PCB order with JLC in case someone from Europe wants some. For the double click, I use 13. I have 13. Because I had 13, 14, and 16 to choose from. And I ended up doing 13. Because it was closest. LGR FBS says compass. I'm not going to add a compass to this. There's feather wings that you could add on top to do it. I do want this to be simple as well. I was thinking maybe like I could add more LEDs. Or a reset button. I guess that was the other thing I was thinking about. But the reset button is easily clickable on the other side. All right, let's order this. So I saved it. If I was good, I would click this and run the DRC, which I will do. Refill. And it has these two errors here that it highlights just on the USB connector, which I know are fine. The thing that I have messed up before is this unconnected items. So that's the thing I actually pay the most attention to. So that looks good. So I'm just going to save it again and close the window. And the 3D viewer goes away. Close this. And I don't need this anymore. Oh, 359. My timing is excellent. Git status. Git add all of these and do v3 add RC circuit for reset. v3 git push ckd. And so now you should be able to get it off my GitHub. Next up is, I think I can manage to order it without giving anything away. I'm already logged into Oshpark, so I think if I just do browse for files and home repos, PCBs, sell a feather, Kicad, and I'm using the stable version, so this should just work. Yay! Oshpark love. I like Oshpark. So we're just going to call this the Sell Feather B3. And take a look at this and like everything looks okay. We've got the two new pads. One thing I messed up is actually like the holes. So it's good to make sure the holes match up. So far so good with that. It does say V3. That's something I would mess up. Forget to update the version. So now this is, if nobody's ever used Oshpark, this is kind of what they do this render overall, and then they do individual renders of like where all the drills are, and they give you explanations of that. Anecdata is asking about IO26, whether it's possible to use it as a regular pin. IO26 is probably not, because it looks like it's used for the chip select. So if you have a SPI, if you have like a SPI RAM or a SPI flash, it's probably using that line as chip select. So if you have like a room module, it's going to be used by the SPI peripheral. Or the RAM. They're on the same SPI bus, but yeah. Probably not. Okay, bottom silk screen, board outline, top layer, bottom solder mask, bottom copper layer. Everything looks good. That looks good. Should I label USB? It's too late. I'm gonna order it. I'm gonna do super swift because I want to get it quickly, which doubles the cost, $23, but I want to actually be able to test that reset circuit again. Oh, for D10. Wait, Is that me using it for D10? Let's start Kicad up. Were you looking at the feather pinout? Was that Unexpected Makers? Or is that in my schematic? IO26. Oh, look at that. You're right. D10 is IO26. Interesting. That's a great catch. That's a really good catch. Yeah, we could do that. This has happened to me so many times where I like it's uploaded to OshPark and I realize that I want to do something else. So, Anecdata, are you trying on my breakout? Is that how you found it? LGR FBS asks, do you make custom versions of Adafruit products? Not typically. But if you're talking about many of something, then email. I'll just call it V3. I basically only version when I actually order it from OshPark, so. Okay, let's do that. So which one do we want to use? If we don't want the IO26 there. Oh man, thank you, Anecdata. You're such a help. So where are we going? We're going to D10. And just playing with the Sola. Okay, awesome. So we're gonna delete that. That's interesting. It's interesting that they brought it out on the Sola, the IO26. I wonder if they break it out on one but not the other, because like can I get you to reconsider IO11 as A2? It's ADC2, so it can't be used as analog when Wi-Fi is on. What else should I use? I'm a little scared to make too many different changes. So IO7, 6 and 7 are unused. So I think I could use IO6 for D10 and basically do whoop all the way around. I think I'll just do that. So IO6. What? My grid is my grid is different. Preferences. Common. I change the grid. Grid style dots. 5 pixels. What the heck? I thought I just changed my grid view. Grid settings. Okay, here we go. This is what I want. Okay. 6 and 7 are ADC1 and are otherwise unused as well. Okay, so you want A2. Okay. And we just used 6, so let's say 7. Hey, everybody's getting a bonus today. And can I shift these all down? Can I do it 7, 8, 9? That might be hard. No, I could shift it 1. And just go diagonally between each one. Okay, let's do that. So Move 7. These 3 go down. How's that? Yeah, Unexpected Maker says, yeah, you've gone completely different pins to me. Yeah, and that's because I'm going from Masala. Like, this is a good example here. I think one thing it was of just, like, getting what's on what side. Unexpected Maker also says ADC2 is usable with Wi-Fi on. Which, clearly, I have not tried yet. So I'm going to delete these 3 ahead of time. And I'm also going to delete this. Because it's going to change. This is really like the heart of when it, like designing a new board, I think, is like figuring out the pin mapping. And then like making sure that you have all the like stuff you need. And maybe I'm wrong because I don't do this. It's not my job, usually. But okay. Keep hoping Osh Park will have the new Teensy in purple. Do they have it in a regular color? Because I think I have ordered it from... I have ordered the new Teensy from Osh Park with an order. Okay. I love Kicad's routing. It's awesome. I get a lot of satisfaction from... Oh. I need to get like a keyboard overlay thing. That's why making a new board design is easier. Pick whatever pins you want. It's true. Okay, Anecdata, are you happy with this? Let's refill. I just hit B, which adjusted the ground fill here. There's a link. Unexpected Maker. Anecdata is talking to you on Discord. But there's a note in the docs that say otherwise. But cool. I think this is what we want. So let's do kind of what we did last time. So we'll do a 3D viewer again, make sure that like our silk screen looks okay, that we haven't placed any vias too close to anything, which we haven't. And even like, especially with the After Dark, like you can also just think about the lines of the traces and how they relate to the silk screen as well. Matt is talking about the Teensy 4.1. Yeah, I have not seen that one. I only saw Teensy 4.0. Okay, so that looks good. Let's run our DRC just to make sure that like we don't have any misconnections, which looks good. We just have the 2 errors with the USB footprint, which is fine. And so we're good. It's still v3. But let's just do the same process again. I'm glad I didn't send you the link. So it's don't use... Actually, maybe I should... Git add, git commit, tweak pin outs. D10 is now IO6. Which A ones did I change? A5 is IO7. A4 is IO8. A3 is IO9. And A2 is IO10. Cool. I think that's it. And I didn't actually do a tag. Nigel says, that logo. You like my chickadee? I like my chickadee logo. We have a bird feeder downstairs, and we always have chickadees at it too. Okay, so I'm going to go back to Osh Park, and I'm going to go back to my projects, and I think, can I delete it? I'm just going to straight up delete it. Wabam. So I can reuse that name. And I'm going to snag it again. And what we're going to want to look for is that the copper changes to make sure that I actually did the latest rev. And that they're not caching by file name or something crazy. Okay. And if we scroll down, the drills are the same, the outline's the same, but here in the top layer, we can see that one, we have the one going over to D10, and we have these 4 diagonal now, which is good. And so we're just going to order it. And nobody find any other mistakes, because I'm over time. Come on. Okay, so I'm going to super swift it again, but I already have it in my cart, so now what I can do is, one, I will share it. So here's the permalink, and I'll post this for you all. Again, this is untested, so order it at your own risk is what I would say. But you've seen me work on it. Hopefully that gives you some sort of confidence. And then I hit order again. And now it's in my cart twice. The first one is marked super swift. The other I'm going to mark after dark because more people should order after dark. Nigel says chickadees are very common where I'm from. Also, is the Sala worth it at this point? Yeah, I think so. If you can find a Sala, pick it up for sure. I mean, they're $8. Like you'll spend more on 3 copies of this board. If you are doing this board and you need links to parts, let me know. And Johnny says mistakes, you only ever find them the day after you ordered the PCBs. Yeah. So yeah, I mean I think the ESP32S2 is a really exciting chip. I would encourage people to get into it. I think that this adapter, until we have a feather, either Unexpected Maker's feather or a feather from Adafruit, is going to be a better option just because I think the feather footprint is better. But until then, this is a good kind of like sanity check on pinouts and stuff. So I'm going to do this. I'm going to check out off screen just to make sure that it doesn't have like my address, which if you really wanted to, you could find, but it's better to make it a little harder. Yeah. Maybe you can see it over the chat. I don't know. I could turn my screen off too. There, we have cat cam. I always get free shipping because I'm like a state away, so it's usually pretty quick anyway. And just put in my email, and then it texts me a confirmation number. Awesome, awesome. And it says, thank you for my order. And I'm getting the emails. Awesome. If enough of us order it, we should fill up the panel and they can send it off. And Mark shows that He's added it to his JLC order as well. Bruce says, okay, I ordered one. If it doesn't work, I want my time back. um, Interesting that it takes a month to get there in Canada. $3.10. Ah, yeah, on JLC. Awesome. It's going to be your gateway into CircuitPython. Yeah, it's still unpolished, but you can do some things. Like, it was weird that when I was saving, it wasn't auto-reloading. So that's one strange thing. Yeah, and Matt's in the Midwest. So reach out to me if you need part numbers and things. So like the USB connector is like the micro USB connector from Adafruit. So if you just go to adafruit.com and maybe, you know, I think I have, typing. Wow. Somebody. But yeah, the USB connector is probably the hardest thing. Everything else is an 0603 part. So like an 0603 LED. And 0603 resistors and capacitors. There's a diode on there that you do need to get the power from the USB, which is an MBR 120, which is a pretty standard part. I don't know if we sell at Adafruit, but you can get it certainly off of DigiKey, which is where I got it. So yeah, if you need help with parts, just reach out to me. I'm happy to help. The STEMMA QT connector and the SWD connector are also from Adafruit as well. I don't know where. Our search is not the best. USB micro. It's like, it's that connector just in a pack. Oh, and you can't see my screen anyway. Sorry. This is what I'm looking at. These are the micro Bs that are on this board. And this is the first thing I solder when I solder it together. Basically, the opposite view of this, you'll see, maybe you can see it. Yeah, here you can see that there's these 5 pins. Those are the things that I solder first. So I'll set it in the slot and just put some flux and then boop, boop, boop. Each one of those is the very first thing I do. And then I do all the other connectors and stuff. All right. 29 cents for shipping. And be there in under a week. Awesome. Well, you can tell me all the things I messed up on it. Okay, we're over time. Thank you all for hanging out. I'm Scott. I work for Adafruit on CircuitPython. Although today was kind of a hardware verification day. I'm going to let Lamore know that, like, hey, I tested the JTAG and it seems to work. So she'll be able to crib a lot of the pinout stuff from this dock if she wants to. But again, on the ESP32S2, there is quite a lot of flexibility when it comes to like I2C, and SPI's a little different, UART's a little different, but in general it's pretty flexible. So thanks for hanging out with me. Next week I should be around, and this setup seems to be working. So hopefully you like the new digs. Let me turn the cameras back on, and you can see that Spook is still asleep in his bed, living the cat life. Next week we'll probably be doing software again because that's primarily what I do. So expect to see. I think my goal at the start of next week is to actually get the native Wi-Fi up and running, and then I'll finish all the libraries on top of that, as well as the ESP32 SPI stuff. So should be cool. I think that's one of the bigger things that people are excited about. I may take a look at that, like, auto reload slowness, which is unfortunate. I think Tiny USB could use an update as well. There's been some improvements on the ESP32S2 support on Tiny USB that would be good to pull in as well. So yeah, I think that's it. Again, please visit adafruit.com and support Adafruit, who contracts with me to work on CircuitPython. They've been great even through the pandemic, as they've had to shut down, and they're rapidly getting everything back in stock. So please order stuff that you see that's in stock there. I think they're getting through the backlog, which is great. And AdaBox just went out, which is super exciting as well. So I think that's it. Thank you all for hanging out. And you can join the Discord. Yeah, that's the last thing. adafru.it/Discord. If you're in like the YouTube chat or any of the other chats, you can go to the Discord. We're there all week. I'm Tan Newt on there. So you can check that out as well. And with that, have a great weekend, and we'll talk to you next week. I'll close on cat cam here. Should I pet him? Oh, did I wake you up? Yeah. The perks for working from home. Thank you all. See you next week.